This video is on Unit 2, Chapter 5 on solving quadratic functions, lesson number 2, solving quadratics by factoring. In the notes here, under solving quadratics by factoring, the steps are: number 1, move all terms to one side and set the equation equal to 0. Secondly, we're going to factor. Thirdly, you're going to set each factor equal to 0 and solve for each x value. And then lastly, you're going to write your answer as a solution set. Keep in mind, sometimes we don't have two solutions. We may just have one. We're going to start out by looking at example number 1. The directions here are just solve each equation by factoring. In number 1, we already have a 0 on the right side, so I'm just going to go ahead and try to factor this x squared plus 9x. For this one, ax squared plus bx is all you got. You do not have a constant, so GCF is your best friend. The greatest common factor here is an x, and I'm going to factor that out and get x plus 9 for the other factor. In step number 3, it says to set each factor equal to 0 and then solve. So my two factors are basically the things that have x's in them. So x and x plus 9 are my two factors. So I'm going to set x equal to 0, and I'm going to take the x plus 9 and set it equal to 0. The first one, x equals 0, is already solved. To solve x plus 9 equals 0, we're going to subtract the 9 and get x equals negative 9. So my two solutions are negative 9 and 0. And honestly, I don't care what order you put those numbers in when you're stating them in the solution set. Let's look at example number 4. Number 4 has got 9x squared minus 25 equal to 0. Again, there's already a 0 on one side, so we're just going to factor. This equation does not have a bx. That's what stands out to me. The bx is missing. So you're very limited on how you can factor this. It's either GCF or difference of squares. So because there's no GCF and it is a difference of squares, I'm going to be able to factor this pretty quick. So the square root of 9x squared is 3x, and the square root of 25 is 5. Again, alternate your signs. So those are my two factors, and then what I'm going to do at that point is I'm going to take my two factors and I'm going to set them equal to 0 and solve. So 3x minus 5 equals 0. Add your 5 and you get 3x equals 5. Divide both sides by 3 and you get 5/3. For 3x plus 5 is equal to 0, we're going to subtract the 5. And then when you divide by 3, you get negative 5/3. So for this one, the shorthand way to write this answer is with a plus and a minus in front of the 5/3. And basically what that means is your solution is a positive 5/3 and a negative 5/3. So let's look now at example number 5. Number 5 says x squared minus 10x plus 21 is equal to 0. Again, 0 is already on the right side, so I'm just going to factor the trinomial that's on the left. The leading coefficient is 1, so I just need two numbers that multiply to give me 21 that add to give me the negative 10, which would be a negative 3 times a negative 7, because negative 3 plus negative 7 is your negative 10. So I can quickly factor this into the x minus 3 and x minus 7. And then I'm going to take those two factors, set them equal to 0, and solve. So add the 3 and add the 7. So my two solutions for number 5 are 3 and 7. I want to jump down to number 7. On number 7, you again have a 0 on one side, so we can just go ahead and factor the left. Now we've got a 3x squared minus 13x minus 30. There is no greatest common factor here. So, but there is a leading coefficient. So what we need to do is find our product sum. Two numbers that multiply to give me negative 90, that add to give me negative 13. which should be 15 and 5. 5 and a negative 15. Nope, just kidding. 18. 5 and negative 18. 5 times negative 18 is going to be negative 90, and 5 plus negative 18 is going to be the negative 13. So to factor this, I'm going to replace the negative 13x with the negative 18x and the 5x. And then I'm going to group, factor by grouping. I'm going to group the 3x squared minus 18x together and the 5x minus 30 together. The greatest common factor for the first set is a 3x, which is going to leave me with x minus 6. The GCF on the second set is a positive 5, leaving me with x minus 6. So this is going to factor into x minus 6 times 3x plus 5. And then don't forget your equals 0. In that middle section, I'm just trying to factor. So I usually leave off the equal 0, but don't forget it because, again, you are solving this quadratic. To finish this off, we need to take both factors and set them equal to 0. So I need x minus 6 equals 0. So add your 6 and you get x equals 6. The 3x plus 5, set it equal to 0. Subtract your 5 and divide by the 3. So my two solutions here are negative 5/3 and a positive 6. Let's jump to number 10. Number 10 says 7x squared plus 8x is equal to x squared. So we've got stuff on both sides. I don't see a 0, so I need to fix that. I'm going to subtract the x squared from both sides. Now, you have an x squared on the left to subtract it from, so it's kind of like you're combining like terms here, but you have to use your opposite operations because they're on opposite sides. 7x squared minus x squared is 6x squared plus 8x is equal to 0. Now, just like I did on number 1, this does not have a constant. So in all quadratics, in standard form, it's ax squared plus bx plus c. And when that constant is missing, you're looking at GCF. Because at the very least, they have an x in common. This has a 2x in common, so I'm going to factor that out, and I get 3x plus 4 equals 0. So I have factored it. I'm going to take my two factors, and I'm going to set them equal to 0. So 2x equals 0, divide by 2, and you still get x equals 0. 3x plus 4 equals 0, subtract the 4, and divide by 3, and we get negative 4/3. So my two solutions for number 10 are a 0 and a negative 4/3. Let's jump down to number 16. Number 16, I have 4x squared plus 41x plus 98 is equal to 2 minus 3x. So here again, we need to have a 0 on one side. We need to subtract the 2 from the 98 and add the 3x to the 41x. So if I add the 3x, it has to be added to the 41x and subtract the 2 from the 98. So I have 4x squared plus 44x plus 96 equals 0. And what happens on this one is we end up with the greatest common factor. The GCF on this is 4. So we're going to factor out the 4. And what's left is x squared plus 11x plus 24 equals 0. Now, looking at the inside, x squared plus 11x plus 24, the leading coefficient on the square term is a 1. So I just need two numbers that multiply to give me 24 that add to give me 11. Which is going to be 3 times 8. So you got your 4 out front, you've got your x plus 3, and your x plus 8 equals 0. Now, the 4 is a factor. X plus 3 is a factor, and x plus 8 is a factor. But the 4 does not have an x on it. So therefore, the 4 does not give me a solution. Only the factors that have an x are going to give you a solution. So take your x plus 3, set it equal to 0, subtract the 3, x equals negative 3. And x plus 8 equals 0, subtract the 8, and you get x equals negative 8. So my two solutions are negative 8 and negative 3. The last one that I want to look at is number 18. On number 18, I'm going to get the 0 on the right side by subtracting the x from the negative 11x minus x will be negative 12x, and add the 9. So that's what that's going to look in that form. There is no greatest common factor between 4 and 12 and 9. So we're left to factor. Normally, I would say multiply the 4 times the 9 and use your product sum table. But I want to talk about something called a perfect square trinomial. In a perfect square trinomial, your ax squared is a perfect square. Your constant is a perfect square. Now, when I say perfect square, it has to be positive, right? So this must be a positive constant in order to be a perfect square. If it were negative, this would not work. The middle term is the square, basically the square root of your first term. So the square root of ax squared times the square root of your constant times 2. So let's go and look at number 18. The square root of 4x squared is 2x. The square root of 9 is 3 times 2. Now the 2 comes from the fact that when you are factoring this using factoring by grouping, the two middle terms end up being the same. So those 2 that we end up adding together to create that bx are identical. That's where the 2 comes from. So if I multiply 2x times 3 times 2, I get 12x. Now it needs to be a negative 12x, but I can fix that by making the 3 negative. This factors into 2x minus 3 squared equals 0. If you understood about the perfect square trinomial, great. If not, then you're going to go back to the old method of multiplying the 4 times the 9 and doing your product sum, two numbers that multiply to give you 36, that add to give you negative 12, and you're going to factor. When you're done factoring, you're going to have 2x minus 3 times 2x minus 3, which is what I have here. The thing is because those two factors are the same, This only has one solution. When my factors are the same, I only have one solution. So I only have to take the 2x minus 3 and set it equal to 0, add the 3, and divide by the 2. So my solution for number 18 is 3 over 2. So those are your notes for chapter 5, lesson number 2.